Welcome to the lecture on AC fundamentals. In this lecture, I am going to explain a few definitions and the terms that are associated with periodic functions. Myself, Satyanarayana Vanapalli, working as Associate Professor in Gunturu Engineering College, Yanamadala, Guntur. So, a period, first see what is meant by a periodic function. A periodic function is one whose magnitude or amplitude repeats at regular intervals of time. So there exist certain functions whose magnitude varies with respect to time. So as the time varies, its magnitude varies. So if you observe those functions, their magnitude variation with respect to time, you can find a similarity in the magnitude values at regular intervals of time. Such kind of functions are known as periodic functions. So mathematically, a periodic function is expressed as f of t is equal to f of t plus capital T, where capital T is known as period or time period. So now see what is the difference between f of t and f of t plus t. This f of t is known as instantaneous value. That means magnitude or amplitude of the function f at a time instant t, and f of t plus t is the magnitude or amplitude of the same function at time instant t is equal to t plus t. That was the difference. If these two values are equal, then such function is called as a periodic function. Now we see what are the examples for periodic functions. The first example is sine function, or we simply call it as a sinusoidal function. Second one is cosine function. Third one is sawtooth function. Fourth one is triangular function. Fifth one is square function. Sixth one is trapezoidal function. So now we see, I try to explain the period, how the sine function is known as a periodic function with the help of a example. So before going into the sinusoidal function, we see what is the definition of an alternating quantity. Alternating quantities are those whose amplitude changes with respect to time. So f of t, we have seen, is a function whose magnitude or amplitude is varying with respect to time. So that this f of t is also known as an alternating quantity. Alternating quantities are periodic in nature. The most of the alternating functions are periodic in nature. And alternating quantities are represented with lowercase letters. So this I will explain when I am going to explain about AC analysis applied to sinusoidal voltages that are applied to electrical circuits elaborately. Here I am showing, this graph shows a sine function or sinusoidal function and its magnitude varying with respect to time or angular displacement. As we know that I have taken a function y is equal to sine theta, and As the theta values are changing, sine function will have different values. You know that when theta is equal to 0 degrees, its value is equal to 0. Sine theta is equal to 0. When theta is equal to pi by 2 or 90 degrees, its value is equal to plus 1. If we increase this theta value in such a way that the theta value is equal to 180 degrees or pi radians, sine pi is equal to 0. And like that, if this theta value are varied in steps of every 90 degrees, I plotted the values of sine function. Sine 3 pi by 2 or sine 270 degrees is equal to minus 1. Sine 2 pi is equal to 0. Sine 5 pi by 2 is equal to plus 1. Sine 3 pi is equal to 0. Sine 7 pi by 2 is equal to minus 1. Sine 2 pi is equal to sine 4 pi is equal to 0. So that the sine values will vary as the value of theta is varying. So on. If you observe, sine function is having same value at theta is equal to pi by 2 and theta is equal to 5 pi by 2. Similarly, at theta is equal to 3 pi by 2, the sine function value is equal to minus 1, and at the theta is equal to 7 pi by 2, its value is equal to minus 1. So, if you take these two instances, at theta is equal to pi by 2, the value is 1. The same 1 is getting repeated at theta is equal to 5 pi by 2. Similarly, at theta is equal to 3 pi by 2, the sine function value is minus 1. Its value is getting repeated at 7 pi by 2. Now you take this 5 pi by 2 can be written as pi by 2 plus 2 pi, and 7 pi by 2 can be written as 3 pi by 2 plus 2 pi. So, comparing with the previous analysis, here this in place of t, we assume that the variable as theta, so that f of 3 pi by 5 pi by 2 is equal to f of pi by 2 plus 2 pi. Similarly, f of 3 pi by 2 is equal to f of 3 pi by 2 plus 2 pi. That means the sine values are getting repeated for every 2 pi radians of angular displacement theta. That means as the theta value is varying, the sine for every variation in 2 pi for every variation of 2 pi radians in theta value, the sine values are getting repeated. So, sine function is periodic in nature, and if you observe this waveform, the sine function is having a maximum value of plus 1 and a negative maximum of minus 1. Negative maximum of minus 1. That means the value of sine function oscillates between plus 1 and minus 1. So, this plus 1 is known as peak value and minus 1 is known as the crest value. And if you observe the graph, the sine function is having positive values in between 0 to pi and negative values in between pi to 2 pi. So if you observe this waveform, half of the values or half of the for the half of the time period sine is having positive values, and for half of remaining for the half of the time it is possessing or having negative values, and these values are getting repeated for every 2 pi radians of time. So the time period of sine waveform is equal to 2 pi radians. Time period of sine waveform is equal to sine function is equal to 2 pi radians. So here, for the sake of convenience, I am representing the maximum value with Pm, positive maximum and negative maximum, and the difference between the peak value and the crest value is equal to 2 Vm. You know that peak value is +1, crest value is -1. Then their difference is 2, 1 minus of -1, which is equal to 1 plus 1, that is equal to 2. I am assuming as I am representing this value with Vm, and negative value, crest value is also equal to minus Vm. The difference will be equal to Vm minus of minus Vm, which is equal to 2 Vm. This value is known as peak to peak value. Sometimes this value is also called as peak to peak value. Now we see the summary of the sine function. Amplitude of sine function oscillates between +1 and -1. This is the first point. As you observe the waveform, the sine function values are varying between -1 and +1. The second one, sinusoidal function is periodic in nature. Sinusoidal function values are getting repeated for at regular intervals of time, and the function repeats itself every 2 pi radians. Therefore, the period of the sine function is 2 pi radians. Now, theta is equal to omega t is equal to 2 pi will become the time period of sine function. So, now we see what are the definitions that are associated with these periodic functions. First we see amplitude or peak amplitude. The maximum positive or negative of a periodic function is known as its amplitude. The maximum value of positive or negative of a periodic function is known as its amplitude. As you take the same example of sine wave, it is having a positive maximum of +1 and a negative maximum of -1. So that is what we call it as the amplitude. Next, cycle. What is meant by a cycle? One complete set of positive and negative values of a periodic function is known as a cycle. One complete set of positive and negative values of periodic function is known as a cycle. So here, if you observe the waveform, I have drawn an yellow color box surrounding a sine wave. If you observe, after 2 pi, theta is greater than 2 pi, its the function value is becoming positive, and these values are getting repeated. So I can say that 0 to pi, the values of sine function are positive, and 5 to 2 pi, the values of sine function are negative. After theta value greater than 2 pi, the same positive and negative values are getting repeated. So we can call the in between the theta values, if the theta value greater than 0 and less than 2 pi, the sine contains a set of complete positive values and complete negative values. That is the reason why this particular part of the waveform is known as cycle. This particular part of waveform is known as a cycle. So, coming to the time period. The time period is the time taken by a periodic function to complete one cycle. It is the time taken by a periodic function to complete one cycle is known as its time period. In general, this time period is measured in seconds. Time period is measured in seconds. Next, coming to the term frequency. So this frequency, it tells about how many number of cycles that the waveform is containing in 1 second. How many number of such cycles, alternating cycles that are existing in a time of 1 second is known as the frequency of periodic function. So the frequency is defined as the number of cycles per second, of a periodic function, and the frequency is represented with the letter f. F is reciprocal of time period. So f is equal to 1 by t and the unit is h. Next, angular or radian frequency. The angular frequency of a sinusoidal function is identified with omega and is defined as omega is equal to 2 pi into f, where f is the frequency. We know that f is reciprocal of time period and its value is equal to 2 pi by t. Next, we define the word phase. The phase is the fraction of time period of an alternating quantity which has elapsed since it passed through zero position of reference. In general, these periodic functions in nature will exist from a time starting from minus infinity to plus infinity, so that it is not possible for us to identify where these waveforms, at what instant of time these waveforms have been started. For that purpose, we take some arbitrary reference. With respect to arbitrary reference, we try to measure the beginning point of the waveform. So this phase will tell how much fraction of time period of the alternating quantity that has elapsed from the reference which we have considered for our analysis. Next, phase difference. The phase difference is the difference of phases of two alternating quantities. In most of the times, if you take two alternating functions, they might not have the same phase with respect to one particular reference. In such cases, we use the word phase difference to express the difference between the phase of the two alternating functions. In general, this phase is measured in degrees. The phase is measured in degrees. In general, we use the word phase angle of the waveform. So, to have a better understanding, here I am showing you the cosine function. This cosine function is also periodic in nature with a time period equal to 2 pi radians and whose value oscillates between +1 and -1. And this waveform is a sawtooth waveform with a peak amplitude is equal to Pm, which is having a positive peak. And this is a triangular waveform. If you observe, the value increases from 0 to Vm and then decreases from Vm to 0 and then increases from 0 to Vm and then decreases from Vm to 0, and if you observe, its value is getting repeated for every t seconds of time. And this is a square function or pulse function with peak amplitude Vm having a time period t, and its value is equal to Vm in between 0 to t by 2, and its value in between t by 2 and t, its magnitude is equal to 0. This function is represented with green colored line, and this is periodic in nature because its magnitude is getting repeated for every t in seconds of time. And this is a trapezoidal function. For the sake of convenience, I have shown one cycle of trapezoidal function whose value is alternating from 0 to Vm, and then it remains constant for particular period of time and then decreases to minus Vm and remains at minus Vm for another a constant interval of time, then goes to 0. So in this class I explained you about the definition of periodic function and examples for periodic function. A sinusoidal function is a periodic in nature, and the terms that are associated with periodic function, they are cycle, time period, frequency, phase difference, and angular frequency, and the shape of the periodic functions. To have continuous access for my videos, I request you to subscribe my channel so that whenever I upload the videos, you can get notifications on your mobile or in your email. Thank you.